Hey, this is Horner, and today when we went through everything, we noticed that when we went through the combo circuit, we had to rank the resistors, which is basically a light bulb, in terms of brightness. And so we're going to do the same thing in this video. We're going to start with the following. It's a combo circuit, and it has the following things in it. So we've got 12 volts for your battery, and then we have a 3 ohm resistor or bulb in series, a 100 ohm bulb in parallel, and a 110 ohm bulb in parallel. So I'll go ahead and draw that now. Now that we've drawn the circuit, next thing we need to do is go ahead and figure out what to do in order to find the bulb that is going to be the brightest. So notice that we do have two different paths here. We have one path that goes this way, and so there's our first path, and our second path is here. So because we've touched that 3 ohm resistor twice, we know that one is in series for sure, and the other two have only been touched once, so they must be in parallel. And so let's back this up then. All right, we need to start by finding the resistance in parallel. So we're going to find this part right here in parallel. Here we go. Now that we've found the resistance in parallel, I'm going to switch to a different color. And I know now, oops, let's switch to a different color. I know now that in this part of the circuit, my total resistance, so I can cross these off, is 52.6 ohms. Now we can find the resistance in series. This is now my resistance in total. At this point, because I have the resistance in total, I can now go through and I can find out what the total current is for the entire circuit. So let's do that next. We now know that in the series part of the circuit, we have 0.216 amps. If I go down to here, you'll notice that the current will change when it gets down to the bottom. But for right now, we know that the current in this part of the circuit is 0.216 amps. We want the brightness of the resistors, and remember there's two equations that we'll use. If you are in series, the brightness is just the power, and the power is equal to I squared times the resistance. So because we now know what the current is, we can go ahead and solve for this. So 0.216 squared times the resistance, which is 3 for this part. And so now we're going to end up with 0.140 watts. That is the power in this resistor. In order to find the power in the other two resistors, because they are in parallel, we have to use the equation P is equal to V squared over R. The problem is we don't know what the voltage is in each one of these. It will be the same, but we need to figure it out. It is not 12, and that's because this part of the circuit takes part of that voltage. So let's figure out how much voltage it takes first. All right, because we know that this takes 0.648 volts, let's figure out how many volts are in each one of these using the loop rule. So remember, the loop rule says that the sum of the voltages in the circuit needs to equal 0. I start with 12 volts, and I am dropping 0.648 volts in that first resistor. And so now we can find out what the voltage is in each one of these, because they will be the same. If I take those two numbers and I subtract them, I should end up with 11.4 volts, and that is what I have left for each one of these two resistors. So 11.4 and 11.4 volts here. At this point, we can go ahead and figure out what the power is in each one of those two resistors. So let's go ahead and do that now. Now that we know what the power is in each one of the three bulbs, which are also resistors, we can go ahead and put down our final answer. We'll do that one in red. We know that the brightest one here, the brightest one is going to be the 100 watt bulb because it is 1.3 watts. It's the 100 ohm bulb, sorry. it is 1.3 watts, so that one is bigger than the 110 ohm bulb, which is much bigger than the last bulb, which was the one in series, which has a brightness or a power of only 0.14, and so this is the 3 ohm bulb, and that is the ranking, and that is how you back up your ranking to make sure that when we grade this, we see all of this work. And that is the end of this question.